Hey math lovers, let's go over number 3. Again, we're solving this systems and then we're going to graph it to verify our answer. Okay, so let me write this problem down below so we have some more space. I have y equals negative x minus 2 and y equals 2x squared plus 16x plus 24. So we said we're going to use this, we're going to solve it by substitution. And the reason why I'm using substitution is because they're both equal to y. So use your highlighter. Every time I see y, we're going to write negative x minus 2. I see y, and instead of writing y, we're going to write negative x minus 2. Negative x minus 2. And I have 2x squared plus 16x plus 24. Okay? Alright, let's set this equal to 0 now. So I'm going to line down the equal sign, some space to work. So I'm going to move this negative x to the other side. So to do that, I'm going to add the opposite and line them up with like terms. So I have 0 equals 2x squared plus 17x plus 26. Okay, let's see if we can solve this by factoring. And remember, a value is 2 here, so I'm going to have to use both the x in the box if the x puzzle works. Let's go ahead and try that. A times c is 52, and my b value is 17. Let's list all the factors of 52. Remember, this visual might help you. 4 goes in 52 once, and 13. And any others? Can't think of any. Which one of those works? 13 and 4. 13 times 4 gives us 52, and 13 plus 4 gives us 17. So those are the two numbers, 13x and 4x. I'm going to take those values from over there, 2x squared and the 26. We're trying to solve this, and the easiest way is by factoring. So let's go ahead and solve this. GCF this way gives me a 2x. GCF this way gives me an x. Going this direction, I have a 2, and this direction I have a 13. So let's just double check that that works. 2x times x gives me 2x squared. 13 times x gives me 13x. 13 times 2 gives me 26. And 2x times 2 gives me 4x. So that works. Let's go ahead and write that over here. So over here in green on the outsides on the right, x plus 2 and 2x plus 13. Again, the order does not matter when you write them. So what we're trying to do is just solve for x here. Let's go ahead and do that. I'm going to set each of those equal to 0 and go ahead and solve those. I get x equals a negative 2, and over here I'm going to subtract 13. 2x equals negative 13, and divide by 2, you're going to get x equals negative 13 over 2, or 2 goes into 13, negative 6.5 times, right? Okay, what do we do after this? We have your x values, and you actually have two solutions. And again, you could have tested that by the discriminant. You didn't need to, but b squared minus 4ac. If it's greater than 0, you have two solutions. Equals 0, you have 1. Or it's less than 0, you have 0 solutions. Okay. So let's go ahead and get a y value. And the easiest way to get a y value is using this linear equation, because it's the easiest to work with. So let's go ahead and bring it down here. Pencil's working. There we go. Y equals negative x minus 2. Y equals negative x minus 2. And let's do the orange one. So negative 2. And let's work with fractions. Fun fractions. Negative 13 halves. Alright, so over here I have y, y equals negative minus 2. So opposite of negative 2 gives me 2 minus 2 is, that would equal 0. So the order pair I have from up here is negative 2, 0. Let's do this one over here in green. I have y equals the opposite of that, minus, I hate when I do that, sorry. There you go. Okay, so let's just simplify the, this is a positive 13 halves minus 2. Okay, how do you make 2 a fraction? Just put it over 1. I need a common denominator, meaning that the bottoms have to be the same. So I can multiply by 2 over 2, and this gives me an equivalent fraction. Let's do that. Y equals 13 halves minus 4 over 2. And I'm just going to subtract the numerators. 13 minus 4 will give me a y equals 9 halves, or 4.5. So from above, that means my order pair is negative 6.5, comma 4.5. So you can do fractions and decimals, is up to you. I think decimals make more sense because it gives us some numbers on it. Okay, let's put those on our graph. Let's go up here. And the orange one was negative 2, 0. So I already know my graphs are going to intersect there. And the green one, negative 6.5, 4.5. Negative 6.5. 1, 2, 3, 4, 5, 6. Negative 6 and 4.5. So somewhere around here, okay? Alright, let's graph these now. Remember that's in slope-intercept form, so there is my y-intercept, negative 2, and it has a negative slope, so that's a negative 1. So this would be down 1, run to the right 1. So from here, down 1, right 1, down 1, right 1. You can do as many times as you want. And you'll get this point here. Okay, so that's my graph in blue. Let's go ahead and graph that. Okay, this one, they're all evens. I'm going to factor out 2. Maybe it makes my numbers a little bit smaller. And let's see if we can factor this one in orange. That'll make my life easier. So in orange, a times c is 12, right? So again, I'm just focusing on the orange here. B value is 8. I get 2 numbers that multiply are 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. So 6, 2. That gives me x plus 6, x plus 2. And we have this 2 on the outside, so I still have that 2. And we're just trying to find the zeros or where it crosses the x-axis, so actually I don't need that. That's it. You can just set each of these equal to 0. Let's just narrow. X plus 2 equals 0. So then you will get x equals negative 6 and x equals negative 2. So those are our, where it crosses our graph. Negative 6. 1, 2, 3, 4, 5, 6. And negative 2. And this graph, do we pick a color? Let's do pink. Pink. Okay, it has a y-intercept of 24. So something way up here, and it's positive, so the graph's going to go up. So the graph's going to look something like this. Okay, so I know it's going to go through that graph twice. I mean, we're supposed to go through that green. And here's an art lesson. If the points you have don't exactly look like you're going to stick it in the graph, because it has to go through that orange and the green dots there. 2 solutions. See you guys.